Shortly after the Big Bang, the universe is a vast, sterile expanse. For millions of years, there is only darkness and the silent movement of drifting hydrogen and helium gas. Despite the immense energy of the early cosmos, it is devoid of the complex chemistry we recognize today. There are no rocky planets, no heavy metals, and no biological building blocks. Across millions of light years, gravity begins to act on this raw matter. It is a slow, relentless process, drawing scattered gas clouds together into increasingly dense pockets of pressure. When the pressure reaches a critical threshold, the centers of these clouds ignite. The first generation of stars, massive blue-white giants, burn into existence, flooding the void with light. Gravity organizes these stars into a brilliant cosmic web, creating the first structured light in a universe that had previously known only darkness. But this era is temporary. Because of their immense size, these early stars burn through their fuel with incredible speed, ensuring they will soon face a violent collapse. Over hundreds of millions of years, the cosmic web draws together to form the first spiral and elliptical galaxies, enormous collections of gas and stars rotating in the deep violet void. At the center of these new galaxies, matter becomes so densely packed that it collapses into supermassive black holes. These black holes are the engines of the galaxy. Their gravitational pull keeps billions of suns in orbit, while their cores erupt with cyan jets of particles traveling at nearly the speed of light. Stars that drift too close to the galactic center are shredded. The same gravitational force that once gave them life now tears them apart, recycling their matter back into the interstellar medium. This mechanical violence is not a sign of a failing universe. It is the necessary preparation for a more complex stage of cosmic evolution. As the first generation of massive stars reaches the end of their lifespan, the internal pressure of their nuclear fusion begins to fail against the weight of their own gravity. A colossal red giant star, unable to sustain its size, collapses inward in a fraction of a second. The star detonates in a supernova. In that instant of extreme heat and pressure, the universe acts as a forge, creating the heavy elements that gas alone could never produce. Carbon, iron, and oxygen are cooked in the heart of the explosion and then blasted out into the dark void, seeding the cosmos with the ingredients for future worlds. Eventually, a shockwave from one of these explosions strikes a quiet cloud of dust in the Milky Way, triggering a localized gravitational collapse. This collapse ignites a new yellow sun and forms a battered young planet, Earth, built entirely from the recycled debris of those first dead stars. Without the violent destruction of the first generation of stars, rocky planets like our own would be physically impossible. The young Earth is a molten landscape. It is a world of lava fields and toxic fumes, constantly bombarded by asteroids in a high-energy environment that seems entirely hostile to life. However, conditions change deep beneath the dark ocean waves, far from the violent surface. Here, hydrothermal vents crack the ocean floor, venting geothermal heat and concentrated minerals, the stardust of dead suns, directly into the water. This mixture of heat and heavy elements facilitates complex prebiotic chemistry, leading to the formation of the first living cells. The lethal, volatile conditions of early Earth provided the exact catalyst needed for these stellar remnants to begin their transition into biology. For 3 billion years, single-celled microbes dominate the oceans. They eventually begin to feed on sunlight, releasing oxygen as a byproduct, and slowly transforming the chemistry of the entire atmosphere. This accumulation of oxygen provided the high-octane fuel required for more complex life. It allowed single cells to cluster together, forming specialized tissues, nervous systems, and eventually the cognitive capacity to process information. Every iron atom in our blood and every calcium atom in our bones can be traced directly back to the core of a dying sun. Our biology is a physical record of the ancient cosmos. A moment of wonder. When we look at the stars today, we are not observing something separate from ourselves. We are the universe finally developing the eyes, the voice, and the mind required to observe itself.